Hey guys, welcome back to Max Electronics, and in today's video we will be looking at this Palsonic TV that a friend of mine asked me to have a look at. Apparently it doesn't turn on. It's an older TV, quite heavy, but he wants it fixed. It's quite old, model TFTV68HDT. So let's have a look what's wrong with it and if we can fix it. Stick around. So here it is plugged in. It is currently consuming 30 milliamps, 0 watts. The standby light is on. So let's try turning it on and see what happens. I heard a click. It's consuming 1 watt, 0.8 of a watt. So it's consuming something. It appears to be on, but nothing comes on the screen. Absolutely black. Let's try turning it off and see if it'll turn off. And nothing happens. So that's it. So let's pull it apart and have a look what's inside and what can be causing the problem. So if it was the backlight, you could do a backlight test by shining a torch on the panel and seeing just where the torch spills the light. You could just see the picture there. So that means no backlight. But since we can't even turn it off anymore, excuse the camera, it's out of focus. Since we can't even turn it off, there must be something wrong with the electronics. So let's open it up and have a look. I've unscrewed that lead. Let's have that removed. We've got plenty of more caps here. I can see that this one looks a bit funny. It's a bit bloated. So let's see, what else do we have here. That would be the audio section here, then main processor. That would be the LVDS processor and video. Oh no, that's HDMI processor actually. Where is the LVDS? Oh, there it is. That's the LVDS. And that would be LVDS processor, and that's probably all the rest of it. So let's start by checking the voltages. So here is the main power cable. There's 2 of them. Three actually. So the first one's a 0 and 24 volts. $5 supply in the next one, then 8 power on, 5 volts. Then I think it's 6, then 12 volts. 12, 5, 5. Oh, that's G, that's not 8. They just pull screen printing, so they're grounds, they're not connected, and then that's for dimmer. Alright, let's get the multimeter on. Okay, the first one we're going to test for is this one. I doubt there'll be any voltage here now, but we'll have a look anyway. Yeah, there's nothing there. Okay, let's check for 5 volts. That should be the standby voltage supply. And we've got 5 volts there, no problem. Now let's turn it on, and as I turn it on, I'll stick the multimeter in here. And turn, oh, it keeps coming off. And turn the mains on, and turn the power on. So it briefly turned it on and turned it off. Okay, let's try disconnecting the main board and just powering the power supply and see if we can, because I can hear a little clicking, which is an indicator that the bootstrap circuit is trying to kick in. So I'll turn the mains off. And I'll disconnect all of those if I can. I've unraveled all the mess and disconnected everything. So let's try to enable the, that's the main one that supplies the power. So let's try to enable the power supply and see if it'll stay on. So for that, I'm going to enable it. And let's see which one. So we've got 5 volts from blue, so 5 volts, 2 grounds, and the power on. So power on with number 4. And let's see if we can short it to ground. No, and then let's short it to 5 volts. No, so it straight away kicks back out. And that's it. So the problem is with the power supply, because just like a computer supply, what I've done, I've short-circuited the enable pin, and that should have turned the power supply on, but it kicks back out. So we know the problem is in a power supply. Let's try disconnecting backlight and resetting it. So I'll turn that off. Disconnect the backlight just in case if it shorts something out in the backlight. So now we've got just the power supply. Nothing's plugged into it, no backlight, no main board. And let's try, I'm just waiting for the caps to discharge so I can re-enable it. Okay, let's try again. And let's try turning it on again. So 1, 2, 3, 4, and 5. And same thing. It just dies off. So the problem is in here. Now, I'm going to turn that off and disconnect the mains. I'm going to take this off the TV and we'll have a look up close on the bench. So here is the main power supply, and what do we know about it? We know when we plug it in, it does work for the standby. We've measured, we had 5 volts out. So obviously the standby circuit is working fine. When we turn it on, however, we know it trips the standby circuit and clicks off the relay. So we know that this part is fine. We know the mains coming in and they're going into this part, and that's your small power supply. We know it's going through this part and everything here is fine. So I think it may be secondary. So first, the primary, sorry. So let's check for diodes. There are diodes here, so I've got it in the diode tester. And the diodes are fine. They're going this way and opposite. They're charging a capacitor. So we've got another diode here. Same thing, charging a capacitor. We've got those filtering diodes here, so those are diodes here as well. Let's check them. That's good that way, and the other way. They're charging a capacitor very slowly. So we've got a little driver MOSFET here that drives this circuit. So let's check this out. Oh, it looks like we've got a short. 0 and full short. So we'll have a look at that first, because even with the bad caps, it should be doing something, but not just flicking it off. So I'm going to get the desoldering gun started. And once that hits up, we're going to desolder that MOSFET, which is right here. And we'll have a look at that first. Also, I will check those caps because they are old and you never know. Even though it seems to be testing out all right, there is no shorts in those caps. That's an important thing. I'm still going to test them out and we'll go from there. So let's check this one part first and then we'll go from there. I have checked everything out. That turned out to be actually diode. It says Q1, but it actually says D1. It's very hard to read. The print is smudged in some places. So I have checked that, and that's fine. I've also checked all the diodes just by probing through in circuit. They all check out fine. Then I've went through all the caps and tested all the caps, and I found that this one, 4.7 50 volt, is a bit off, so I've replaced it. And I've replaced those two, which is 1000 microfarad 10 volts. I didn't have any 10, so I put 25 volts. And the 220, 2200 microfarad 10 volts, which I've replaced as well. And checked all the, continued in everything through without desoldering, and everything checked out just fine. Those are diodes, they all checked out fine. That's a diode, it's fine. That's a diode is fine, another diode and another, those two transistors, they are fine, and another transistor is fine as well. So bridge rectifiers are alright, and we know they're fine. This cap is fine, so those little ones, everything checked out. So that leaves us, that's a little transistor that switches the power on. So once we put 5 volts in it, it turns on and enables the relay, which is this one, which clicks off because apparently it's an overload. So that leaves us with a few things. That's those two diodes as well. Those two, that's the TL's 431. I've replaced them. They're right here. And that's those 3 caps. So that's the only thing I replaced. I haven't tested them. They're really hard to test, and I couldn't be bothered. So I've just replaced them just to see, because they're the ones that are driving the optocouplers. And the optocouplers obviously control the circuit. So it either leaves us with those two, which I've replaced, and we'll see if it'll turn on. Or another thing, it could be one of those chips. I haven't looked at the data sheet for that. That would be the driver for the switch mode. And that would be the driver for switch mode as well. I'm pretty sure that's it for the chips. There's another one here. And I believe those are identical. I have to check on that. So we're going to power the board up and see if it turns on. If it does, then it was definitely, I wouldn't say it was caps. They weren't far off the value, but I've replaced them anyway. If it turns on, it would have been definitely the TL diode kind of things. If it doesn't, then it's definitely one of the chips, and I assume that it wouldn't be this one. It would be either this one or this one. So then I'll have a look what they are and if I have any spares. So let's give it a try. So I'm plugging the mains in. Just make sure there's nothing metal under the board. Just to be safe, there's a little solder ball. Alright, so where is my little jumper? So it's 1, 2, 3, 4, and 5. So I'm applying the power to it now. And let's turn it on right now. I don't know if I heard it click off. Let's unplug it. Yeah, it clicked off. So that leaves us with either the ICs, one of the ICs. So let me just get the data sheets, and we will see if well, there's no 5 volts to trigger that, so it happens here. I think it may be this IC. Let me have a look if I have any spares, because they're not connected circuits. So let me give me a second. Let me just check out the IC's data sheets, and we'll come back to it. I've done a bit of looking around, and I've checked all the caps. They're fine. I've checked the diodes. I found a bit of a hidden fault that I'm still looking at. But what I've done, I have tested the circuit, and I will show you how I've done this. So we've got also power factor correction circuit here. As you can see, there's an inductor and the 2 transistors driving it. And the big MOSFET or transistor, here it is, which I've desoldered. And what I've done also is shorted out the contacts on the relay by putting a little shunt in between the contacts. And now we're going to turn it on, so the power factor corrector is out of circuit, and the problem is not where I thought it would be. So if I turn it on right now, it is consuming, it's dropping again for 4 watts. And if we check with the multimeter, let's check for 24 volts presence. Let me get the probes on there. There we go, we've got 27.5 volts. So a bit over 24, but there's no load, you've got to bear that in mind. Keep slipping the probes. So we've got the voltage here, no problem. Now let's look for 12 volts. 11.71. Again, that's pretty close. So we've got the voltage from this transformer. Let's have a look at 5 volts, however. And we've got 5 volts right now, but if I try to start the relay, as you heard the clicking, and now it doesn't click anymore. And let's check for 5 volts again. Five volts have disappeared. However, the 12 volts still there, and the 24 volts still there. So the problem is in the 5 volt circuitry. The 5 volt circuitry is the one that controls the relay, remember that? So when we give the 5 volts to there, suddenly what happens is the 5 volt disappears, and that's what powers down the rest of the circuit. So that's the thing. So I've checked the output side of it. So the capacitors are good, the coil, the diodes are good, and that's all there is involved in 5 volts. So there's literally a transformer goes straight to the diode. I'll show you in a second. Let me de-energize the circuit. And let me just quickly discharge the capacitor. That should be good. So here's our output. We literally have the transformer. That plane's going to the ground, straight in. This one is going straight to the diode. From the diode, it goes to the capacitor, which is good, through the coil to another capacitor, which is good also. The coil is good also. And then it goes straight to output 5 volts. That's the one we're sending to the power on, that triggers transistor, that triggers relay. But as you heard, it clicked a couple of times and it dies off. So the problem has to be lying on the hot side here somewhere. So optocoupler would be good because it is giving us 5 volts. The suspicion that I'm having now, either the diode here, no, I've checked the diodes. So we'll check the capacitor, we'll replace that capacitor, and we'll check this. I'll check the circuitry around here and see why it is under any little tiny load like a relay, straight away trips the chip. So it's almost like it's pulling it down, and relay can't do that. That's my little shunt that I did, by the way. You can't even see it. So let me check this all out, and I'll check. I'll check the bulk capacitor actually as well. We'll check that, and I'll check any surrounding components in here. That's our 5 volts. Again, we've already replaced the TL341. There is nothing really else that can go wrong. So let me go around with this. We know this side's good, 24 volts. That's the same 24 as this one. So that's all good. It's just somewhere 5 volts. That is not enough to trigger that even relay yet output voltage to the main board. I have desoldered the bulk capacitor for 5 volts power supply. It is 400 volts, 82 microfarads. So let's test it. I have already tested it, but I will show you in a test anyway. Let's test it with the capacitance ESI tester and see what that says. 111 picofarad. No voltage loss, no nothing. I thought it was bad contacts, but it's not. Let's now test it with a parallel resistance tester and see what that says. So we turn it on, and we set it to electrolytic capacitor discharge, so we're ready to test, and nothing happens. So it is literally open. That's why we are probably having our problems. Let me find another replacement for 400 volts, 82 microfarad. It is literally open, but before we do that, I'm very curious to see what's inside. So shall we open that capacitor and see what's inside? So you see how a simple problem like this capacitor can cause you to wonder what's going on, and we did get 5 volts there, remember? We didn't get any other voltage, but 5 volts was there, and it was triggering the relay, but as soon as the relay was triggered, it would flick it back off. So you would think it's an overload. The first thing you'd think maybe the diodes are shorted, maybe there's a capacitors on the output line shorted, but it is not what it is. So I've already gotten that off. You can see the electrolyte, it is still wet. but there is no contact between the pins. So it must be faulty capacitor. Alright, I'm going to find the replacement, we'll plug it in and we'll see if that will work. I have replaced the bulk capacitor for 5 volts rails. It is energized right now, so let's measure if we do have 5 volts now. Well, let me get the meter there. So, 5 volts. Yes, we have 5 volts. Now let's try to trigger the relay. I will lose contact here. Let's see if 5 volts is still there. 5 volts is still there. Let's see if 12 is there. Yep, 12 is there. Let's see if 24 is there. And it is. And obviously 24 volts would be here as well. There we go. 23, 24 volts. So that looks like it's working now. I'm going to put this MOSFET for the power factor correction, because right now, let's see actually the power factor correction. It is very bad. It's 0.3, the power factor. So I'm going to turn this off. That is back in, and I'm ready to test it. So at the moment I've still got a current limiting on, so I'll turn that on. And let's measure the voltage to make sure that everything is still there. So 5 volts is still here, so let's turn it on. Okay, so we've got limiter kicked in, so I'll turn that off for a second and turn the limiter off, and let's hope it doesn't go bang now. Okay, the power factor now, let's see if the voltages are still there. Yep, still there, and the power factor actually was 0.095. So it appears that the board is now working, so the culprit was that bulk capacitor. I'm going to check the main board on the TV, so I'll turn that off. And I'm going to check the main board on the TV. There's a few capacitors there on the low side just to make sure that they are right, and then we'll test it out. The board is back in, and I've checked those caps here. They seem to be good. So let's plug it in and see if it will work now. So I'm going to apply the power now. Let's see what we've got on this side. So we've got a red light. Excuse the angle, it's really hard for me to operate everything. Alright, I'm pressing the power button now. I heard a click. The green light's flashing. And yay! Here we go, the TV is on. And let's turn it off. And it works. Alright. Oh, it's heavy. It is old TV, so it's got heavy stuff in there. But yeah, so we fixed it. And again, this is just shows how easy it is to simply miss something as simple and as easy as this bulk capacitor on 5 volt rail, and how it can mislead you by showing you that there is a 5 volts on offline standby mode and then just disappear, making you think that something else is involved. As you heard me say before, that okay, we're thinking maybe it's on this side, or maybe it is the power factor correction circuit. But again, something as simple as the bulk cap, that they don't usually go bad. They very rarely go bad. It was open and it was not enough power to supply. It was supplying initial power, but as soon as the relay got triggered, it would shut the chip down, and the 5 volt disappears, making you think that okay, maybe something it triggers on this side, and the power factor corrector is doing something to signal the chip to shut off because there's another fault. So that's it. Check simple things first as well, and that could help you resolve problem a lot faster. But that's it for this video. I hope you enjoyed it. Don't forget to like and subscribe. My name is Max. I will see you next time. Bye.